This video is meant to address some of the topics in section 1.2 in your Pre-Calc 1 course. There was a previous video that addressed all of the sections about identifying functions and what is a function and what is not a function of x. This section is meant to address working with functions and function notation, identifying domain and range, and those type of topics that are also covered in this section. So in algebra, when we first start looking at functions, we usually see them in this notation, this y equals x squared minus 2. But we can also look at an equation in the function notation. So we have f of x. We've just replaced our y with f of x. The rest of this remains the same, x squared minus 2. It becomes very clear now that we can do f of 1. We just plug 1 in wherever we see x. So f of 1 will become 1 squared minus 2. There's several questions in the problems assigned for this section that deal with having an f of x and plugging a value in for x. And then there's several questions about graphing. So I thought we'd just go through one example and we can see both aspects here. So if we want to, we have this function, f of x equals x squared minus 2. We want to plug in several points so we get a feel for what the graph looks like. We want to get ordered pairs and we want to graph it. So we'll go through that process. The first step is to plug in each of these numbers for x. So here we have, we want x equal negative 2. So we have f of negative 2. We want to plug in negative 2 wherever we see x. So we're going to plug in negative 2 for x. So we had x squared. So this becomes negative 2 squared minus 2. Now we can evaluate this. Negative 2 squared, negative 2 times negative 2 is positive 4 minus 2. And 4 minus 2 is just 2. So we have f of negative 2 is equal to 2. And I wrote this over here as an xy, but we can also write this as x and f of x. So here, this ordered pair becomes negative 2 and 2. And we can do the same thing with all these down here. I'm going to go through these kind of quick. We have f of negative 1, so we plug negative 1 in, negative 1 squared minus 2. Well, negative 1 squared is 1 minus 2 is negative 1. So our second ordered pair is negative 1, negative 1. F of 0 is 0 squared minus 2. 0 squared is 0 minus 2, just negative 2. So our third ordered pair is going to be 0, negative 2. And f of 1, we plug 1 in where we see x. 1 squared minus 2. 1 squared is just 1 minus 2 is negative 1. So this is 1, negative 1. F of 2, I'm going to plug 2 in where we see x. So this becomes 2 squared minus 2. 2 squared is 4 minus 2 is equal to 2. So this ordered pair is 2, 2. Okay. So once we have all of these, we've plugged them in. We found our f of x. We have our ordered pairs. We can now graph them. And we're just going to plot these points. We have negative 2, 2 is here. Negative 1 is here. We have 0, negative 2 is here. We have 1, negative 1 is there. And we have 2, 2 is here. So now we can draw a smooth curve through these points. Pretty much. And we have a graph of our function. Now there's some of these problems that are in your problem set where they would ask you to graph y equals x squared as well as this one and ask you what the relationship in the graphs are. So in this case, it would be shifted down to. But you're going to actually do all of the points for both of the functions, plug them in, graph them, and evaluate. They're going to be shifted up, shifted down, shifted left, shifted right by however many units. This is something that they get into further in the chapter, and I think these problems are just to start you thinking in that manner. Okay. The other thing that we're often asked to do is not plug in a number, but plug in another variable. So very oftentimes when we're evaluating functions, we want to plug in negative x into the function. So just like we did with the numbers, wherever we see x, we're going to plug in our negative x. So this becomes negative x squared minus 2. Right? So negative x times negative x is just x squared. The negative times the negative is a positive. So we can just write that as x squared minus 2. So our simplified version of f of negative x is x squared minus 2. And you'll notice that this is the same as this, and that's an even, defines it as an even function. But again, this is something that you need to know the mechanics of doing, and we'll get into the implications later in the course. The other section of this is evaluating our domain and our range and our intercepts. In this section here, we have, I have a couple examples here that we'll take a look at. Our domain, and this is going to be true, this is a linear equation of all of our linear equations. Although this graph stops here at what, like 4 and someplace up here, almost at 3, it continues on. So we can plug in any value of x, and we're going to get a value of y. This is going to continue on infinitely. So our domain is negative infinity to infinity. Same thing with our range. Like we stopped our graph at negative 10 and 10, but that doesn't mean that the graph of that line stops there. This line, we have arrows. It's going on infinitely in either direction. So this is negative infinity to infinity. Whenever we have infinity, we want to use these rounded brackets. These rounded brackets mean that it's up to but not included, or you'll use it with like less than or greater than notation. We want to use the rounded brackets for that, but we can never get to infinity, so we always want to use the rounded brackets there. This graph, we have a parabola here, right? Same deal. If we have, like, I don't know what this is, but we have an x squared, x, and a constant, and we want to evaluate the domain. We can plug in any number of x, just like I said before, we stopped here at 6 and negative 2, but it doesn't mean that the function stops there. It's just our graph of that function stopped there. So our domain is going to be negative infinity to infinity. However, our range is a little bit different. We don't have any points below this vertex. And this vertex here is at negative 1. So that's the lowest y value that we have. So we're going to start at negative 1. And we want to use a square bracket because negative 1 is an actual point. So we want to include that. So these square brackets include that point. And the square brackets go with our filled in circles, go with our less than or equal to, greater than or equal to type scenarios. And again, here, if we had an open circle, we would use the rounded bracket. Okay, so 1, and it goes off infinitely large as we continue in our x directions. Okay, now our x-intercept, it's just where we cross our x-axis. So we can see this graph crosses our x-axis at 1 and 3. So we can write this in a couple ways. We can write this as x equals 1 and 3, or we can write this as an ordered pair. So this point here and this point here. This point here is 1, 0. This point here is 3, 0. And you'll notice with our x-intercepts, it's where our y is equal to 0. Okay, and you should consult your notes, your lecture notes, and how your teacher writes this as to how they want you to report it, if they want you to report it in this x equals notation or as an ordered pair. And follow that. I think there's either one is acceptable, but look to see what your teacher, how your teacher did it to make sure that you get the right format in your answers. Now our y-intercept is where our x equals 0, and that's here. It crosses our y-axis at 3. So this is 3. And again, we can write this as an ordered pair. Our x was 0, our y was 3. Okay. And this final example here, we have a truncated portion, a truncated graph, or a part of a graph that's limited. And you can see here, again, our domain is our x and our range is our y. So we want to know all of our possible x values. And this goes down here, right? Our possible x values are 2 to 2. Because these are filled in circles, we're going to use the square brackets. -2 to 2. And our y values go from 1 to 3. Okay. Our x-intercepts, well, there's no place in this graph where it crosses the x-axis, so this is none. Our y-intercept is where it crosses the y-axis, which is here at 1. So again, this is going to be 1, or we can write this as 0, 1. Okay. So I think that pretty much wraps up the other sections for chapter 1.2. Remember that we can write any y equals whatever in terms of x as a in function notation, where we replace our y with our f of x. We plug in numbers for our x to get values. We can also plug in variables or different values for our x that are non-numerical. Our domain is all of our possible x values. Our range is all of our possible y values. So I hope this was helpful.